Hi everyone, welcome to the run through for your retrieval test on sets and Venn diagrams. We've got question one here, which says that each student in a group of 32 students was asked the following question. If they have a desktop computer, would you call them D, laptop L, or tablet D? These are the responses we had, and we have to use this information to complete the Venn diagram that is shown here. When you're given this sort of list, you'll normally see that things appear in sort of three groups. The first three, you've got their students who have one particular thing. There are people who could have a desktop, but they could also have a laptop or a tablet, but there are 19 people who at least have a desktop as total. That means that this circle here adds up to 19. In the same way, this circle is going to add up to the laptop one of 17 and this one 16. The next group, three, you can see these are people who have two. Let's make that a bit more clear. Who have at least two of them. So 9 students have both a desktop and a laptop, but some of those 9 students will also have a tablet. These people here in this middle group are the ones that go in these groups. So like, for example, this is the desktop and laptop people. This is the desktop and tablet people. And this is the tablet and laptop people. And the last bit, we've got 5 students who have all three. Now those people go in the middle. That's the first piece of information that we've got. So I've dealt with that. I can now ignore it. When I look at the next bit up, 7 students have a laptop and a tablet. Laptop and tablet crossover is here. So we're looking at here. Now, if there's 7 students there, and you've already got 5 taken up, that means you've got 2 left over. Just 7 take away. So 7 take away 5. Next up, it says that 11 students have a desktop and tablet. Desktop, tablet, so this crossover. And again, if I do 11 take away 5, I've got 6. And similarly, for the 9 students who have a desktop and a laptop, they're this crossover, 5 already taken, 9 take away 5, I've got 4. So I've now dealt with all of these ones as well, leaving me just with these ones who only have one of the 3 things, or have at least one of the 3 things. So 16 students have a tablet. So this full circle must add up to 16, but you can see that between all of these things that I've got here, I've got 6, 5, and 2. So I've already got 13. But if there's 16 in total, that means I must have 3 more. In a similar way, when I look at the laptop bit, there are 17 in total. But looking at this list of things here, I've got 11 so far, which means I need 6 more to make 17. And last but not least, I can see here I've got 15 already in this desktop computer group, but I need 19, so I need 4 more. 15 plus 4 being 19. So we're almost done. But notice a little sneaky dotted line here for the people who are not in this group. We notice the final bit of information, or the first bit of information really, is that there's 32 students. If you were to add up all of these numbers here, you would actually get 30. And that means that there's 2 left over. 32 take away 2. Okay. After that, it says one of the students with both a desktop computer and a laptop is chosen at random. Find the probability that the student also has a tablet. So there's a few ways to think about this. This is a conditional probability question. But what I can do is I can sort of highlight a particular area that I'm interested in, which is that the students who have both a desktop computer and a laptop. So desktop computer and laptop means that they're in this zone here. This is the only bit I'm interested in, that 4 and 5. Now, from that 4 and 5, the probability of someone owning a tablet is 5 out of the total 4 plus 5, which is 9. And that's what I'll put. This is basically 5 ninths. In probability terms, this is actually a conditional probability. I would say this is the probability of a tablet, which is what we're looking at, given that they are in the set D intersect L, desktop and laptop. So D intersect L is that bit that I shaded earlier, and then we're literally looking at what's the probability of a tablet from that group. You don't need to worry about that notation there, but you need to know how to find that final answer, being 5 ninths. Now, it's worth noting, actually, if you got that bit wrong, but you actually got it right for your numbers, so let's say, for example, your 4 and 5 were not 4 and 5 in part A, you got different numbers, but what you calculated was correct for your Venn diagram, you do get those marks. Okay, question 2. It says the Venn diagram shows a universal set, epsilon, and 3 sets x, y, and z. You can see there are some missing bits here, this one and this one. Okay, it says the numbers shown in each bit shows the number of elements. So there's 7 people here, 4 people here, so on and so forth. It then says n in brackets x dashed is equal to 14. That means the number of elements in the set x dashed, or the number of elements not in set x, is 14. Well, let's look at all those numbers first of all. The bits that are not in x is this set here, so let's ignore that for a second. And I've got the 3, and the 2, and this mystery one here. So let's call this a, for example. Okay, that means that 3 plus 3 plus 2 plus a is equal to 14. Let's just get rid of all this. So this is a. And just note down what I've said there. That 3 plus 3 plus 2 plus a is equal to 14. Well, 3 plus 3 plus 2 is 8. So 8 plus a is 14. That would mean that a would have to be 6. So I've got straight away that this value is 6. But then the other bit says nz is 14. That means the number of elements in set z is 14. Set z is this circle here. So that's this number. Let's call it b, 0, 3, and r, 6 from before. So let's add those up. So b plus 0 plus 3 plus 6 is also equal to 14. Let's write that out. b plus 0 plus 3 plus 6 is equal to 14. Well, 0, 3, and 6 add up to give 9. So I could have b plus 9 is 14. And when I take away 9 from both sides, I'll get b is equal to 5. Now, ironically, that was actually the question. I can actually get to that point of saying complete the Venn diagram. I've already done it. I've got 5 and 6 in these two positions. Then it says find the value of x union z. So I'm thinking of x union z. That means I want all of x and all of z, because it's x union z means it can be from x or from z. So I want the 7, the 4, the 5, the 0, the 6, and the 3. That's what I'm going to add up for that one. That's literally what I'll write. I'll write the 7 plus the 4 plus the 5 plus the 0, not that it makes a difference, plus the 3 plus the 6. And it all adds together to give 25. Again, if your answer is correct based on your Venn diagram, you can still have the marks for this, even if it's not correct for what is on our number here. And the next one, the number of elements in x intersect y dash. So that means the elements that are in x and not in y. Well, this is the set of x. This is the set of y, so I want the bits that are in this set and not in this set. You'll see that it's the 7 and the 5, because this bit is x, this bit is x and y. I don't want those two bits because they're in y, so it's just the 7 and the 5. So 7 plus 5, and I've got 12. And again, if your answer was correct based on your numbers that are on the Venn diagram, you can still have 5 marks there. Okay, there we go, job done. Hope that was okay, and we'll see you later.